Zx, okay? And this is also equal to your tau max, right? So this will be equal. So if you look at the circle, right? We know this value now. We know our stress average, right? And then we are going to put in our shear xz, which we also know. Okay, our shear xz is this value over here. Okay, this value over here. So this will be equal. Okay. Any questions so far? Because I need to relate this mole circle. Then we know what those values mean. Okay. You don't know. You cannot relate mole circle. You're like, where are we now? I was the same. Okay. So this will be equal to minus 2500 C minus by 72,000 divided by 2 pi C cube, the whole thing squared, plus by 55,200 over pi C cube, and the whole thing is also squared. Okay. So now immediately we can substitute to find our stress A and stress B. Okay. So stress A. Now, why do we need to find stress A and stress B? Is because our circle, one is in what? Tensile mode. The other one is in compression mode, right? You can see that, right? So that's why we have to identify stress A and stress B. All right. So we're going to look at stress A and stress B now to find stress A and stress B. So I'll copy this circle if you guys were wondering what we are trying to do down here. Okay. So we are trying to find, so stress A and stress B is equal to the stress average plus and minus tau max. Or I'll put down here radius of the circle. Okay. So this will be equal to, so stress A and stress B. Okay. So stress average is equal to what's our stress average? Wait, let me see what's our, so our stress, I'm just going to copy from here. Okay. So this is our stress average. Okay. And then we are going to do plus minus. And then we have the square root. All right. Square root of what? The whole thing. I'll copy from there. Okay. So I wouldn't waste your time. By the radius. Okay. Right. So this is to get stress A and B. Okay. So we have to meet this criteria now. Okay. So we're going to implement Tresca, where this is stress A minus by stress B. Right? Because stress A and stress B, it can be equal to your stress max minus by your stress mean. Okay, so this is Tresca criteria. Okay. So we know that, so stress A and B, so one is plus, the other one is minus, right? So when that's the case, if I were to write stress A, okay, I'll write what is stress A first, okay? So this plus, okay, so this is my stress A. So stress A, for example, stress A is my plus, right? Stress B will be my minus,
Does it matter if it's positive and one's minus, like if you switch them?
That's not matter. Sorry, I was so focused, and when you, yeah, I got it right. It's not you, it's me. Okay, does not matter. Okay, A or B, B or A does not matter. Does that make sense to you? Right, does not matter because we are at a point now that if you call this stress A, stress B, or you call this stress B, and this is stress A, does not matter. Okay.
Thanks.
Okay. Because they're all vector, right? So that's why it does not matter. If it's just negative, it doesn't matter. So now when we put in we substitute where stress Y is equal to stress A minus stress B, right? So we have this whole value over here. Okay. We have this whole value over here. And then we minus, right? We're going to put a, do I have a big enough space? I think I might. Maybe not. Okay, I move this across so you can see better. This is all just math now, okay? This is all just math now. Okay, so this will be minus, I'm going to put another big bracket, the V value. Okay. All right. Let me move it across. You all don't need to copy, okay? This is just a lot of writing, and I don't think it's necessary, or you will have these notes anyway, right? So you have this now with another bracket down here, okay? So now we can cancel, okay? We can cancel here because this minus will be plus. If you can take that away. So the final form, right? So this will be equal to square root twice. Okay, twice. So this will be square root by minus 2500, okay, C minus 72,000 divided by 2 pi C cube, right? And this thing squared plus by 55 200 over pi C cube squared. Okay, so this is equal to your stress Y, or U stress is equal to stress A minus stress B, right? So from here, you know that your stress U is equal to what was it? If we look at values, the U stress is equal to 100. Okay, 100 times 10 to the power 3. So this will be equal to 100. Okay, this will be equal to 100 times 10 to the power 3 is equal to 2. Okay, then you have square root of minus 2,500 C minus by 72,000, okay, over 2 pi C cube squared plus by 52,000, okay, pi C cube, okay, and this is squared, right? So to simplify things just slightly, 50 times 10 to the power 3 will be equal to the square root of minus 2500C minus by 72,000 divided by 2 pi C cube squared plus by 52,200. So we are going to solve this equation using You decide what you want to use, okay? Because there's one equation, okay, one unknown, we can solve it, right? So you can, what software do you all know to solve this? Anyone? I'm going to print this first. How will you solve this? Anyone? What software will you use? Hello? I'm going to see. So can someone, what are you going to use?
Excel.
Are you,
Excel.
Yep, you can use Excel. You can use Wolfram Alpha, CatRam Alpha, whatever, okay? So I'm going to show you how to solve this using Excel, okay? I don't know whether your math instructor teach you, I don't know, okay? So I'm going to turn on Excel. Okay, I'm going to turn on Excel. So before I solve using Excel, I have to move some things, okay? So the thing that I have to move, okay, so is this whole equation over here, right? So I'm going to use this whole equation, minus 50 times 10 to the power 3, the whole thing is equal to 0. Okay, so this is the equation that we are trying to solve, okay? So let me copy this equation. And then let me launch Excel. Excel, my favorite software. Okay. And let me paste. Okay. So this is the equation that we're trying to solve. Okay. So I'm going to teach you. Now all these are recorded. You can later watch. Okay. So this is the equation. So we have to need, C is the changing one, right? C. So C is in changing one, it's in inches. In fact, what I'm doing is not ideal. Why it's not ideal? Because you should do a hand calculation first, then check whether it's a hand calculation correct, then plug in Excel. I'll tell you why. So now I put C is equal to 2. Okay. So the first term, right? So I'm going to focus on the left hand, this term. You all can see my Excel, yes? Okay. So I'm going to key in that term first. Okay. So this is equal to minus, or I have to put square bracket to the power of 2 first. Okay. Then I have to put another bracket and then divide. So numerator divide by denominator. So this will be equal to minus 2500 multiplied by C minus by 72,000, 1, 2, 3. Okay. And then over here will be 2 times by pi. Okay. And is that all? 2 times by pi times by C. Okay, which is this again. And then power of 3. Okay. So the ideal thing is to check once you have this value, right? Once you have this value over here, you have to check by pressing your calculator. Okay. Yeah, 2 is just random. Jenna, thank you for telling me. Okay, it's just random. You can put 1. Okay, you can put 2. Okay, you can put 3, whatever. So I'm going to put 2, and I'm going to check with my calculator. Okay, so 2500 times 2 plus by 72, 1, 2, 3, divide by 2, divide by shift pi, divide by 2 power 3. I get a weird number. No, it's me pressing the calculator. So 2500 multiplied by 2 plus by 72, 1, 2, 3. Divide by 2, divide by shift pi, divide by 2 power 3. And then square the whole thing. I get 41375. I don't get the same number. Shoot. Did I do something wrong? Wait, let me do it again, okay? As I said, this is not the ideal case to do this, okay? You have to do a hand calculation first. And then square 2, 3, 4, 6, 6, 1, 4. I'm spot on. Okay. Then the next one, we are going to program this term. So if you put in the entire this equation on the left hand side down here, we just put in 2, you should get 2, 3, 4, 4, 6.